First of all, I'd like to just comment that a lot of the base concepts we're going to talk about today throughout the entire hour that you have with us is going to be really focused on something that comes out of the ICS 515 course from SANS, and it's obviously tied directly to the grid certification, so the GAC response and industrial defense. So I'm going to jump right in. We do have a lot of material, so we're going to be going along fairly quickly, but we do have time for questions as well. So I want to quickly talk about the sliding scale of cybersecurity. And so two of the main questions we really want to ask ourselves as ICS defenders or a utility or an enterprise with an ICS component is, where are we on this sliding scale of cybersecurity today, and where do we want to be? So I'll kind of just quickly run through these kind of colored buckets to understand what they mean, where you can be slotted into, and understand what your roadmap is moving forward. Recognizing, of course, that this will take some resources, but also people using tools as well as we get up and through active defense. So I want to first talk about, on the left-hand side, we really talk about architecture, how the industrial control system is built from a cyber point of view. So for example, network segmentation, things like that, hardening of devices, vulnerability assessments, and those things can kind of be lumped into that category. When we move over to things like passive defense, we're really talking about technologies that are in place that are almost hands-off. You can kind of set them up, tune them slightly, but for the most part, they do what they need to do. For example, antivirus or whitelisting, for example, and patching and stuff as well. Patching is not a defense mechanism, it's just maintenance. So architecture, passive defense for the first two stages of the sliding scale. And then we really want to talk about active defense. Active defense is really kind of where we are pushing the community to today. That's where we should be as an organization or a community to fend off what we're seeing out there in the wild. So by no stretch am I suggesting, hey, everybody should just do active defense because it's fun. And it is fun, don't get me wrong, but it's almost that the adversary is pushing us in this direction based on their volume and sophistication of the threats that they're actually coming at us with. So again, as I mentioned, active defense is really going to be about looking in the network, network security monitoring, understanding what your ICS is doing on a normal day, and then quickly picking up on abnormalities in that during the process. So active defense is looking at the network, having people look at the network, but obviously using tools to make that looking and threat hunting easier, for example. So I won't go any further in the sliding scale, but that's kind of the crux of what we want to talk about today. It lays the groundwork for Dennis's presentation, active defense. So the second point I want to talk about, we'll really touch on the ICS threats that we have out there, the ICS kill chain, how we determine where the adversary can get in or how they craft their attacks, and obviously how we can detect them coming in as well. But I also want to touch on IT-related malware and IT-related threats that could also impact the ICS. So typically, a threat against the ICS can have one of two stages, or at least it can have stage one and stage two. In stage one, as we see in the chart here, we have threats that we've seen in the past that didn't have serious impacts. It definitely had some impacts, but we'll take Havox as an example. Havox is a type of malware family that did not have any destructive capabilities whatsoever, but it was very effective at what it was trying to do, which was get into an ICS environment and extract information out potentially for later on follow-up stage two impacts to a threat. So stage one, we see kind of the reconnaissance phase, the understanding of an ICS, and stage two is really the execution of what was learned in stage one and getting persistent access to an ICS for the adversary and causing impact. So if we go from stage one, where Havox exists there in kind of the middle or over to the left a little bit, we quickly see the heat map changes color as you shift to stage two. That's where you're going to have the biggest impact. That's where everybody is so concerned in the ICS. But the idea with the ICS kill chain and network security monitoring is to understand how the adversary first initiates stage one, do detection there well before they can get to stage two. So at the end, so I'll talk quickly about Stuxnet that a lot of folks have really heard about, and we've battered back and forth in the community for quite some time. A lot of folks know about the power grid outages as well in the Ukraine that happened in 2015, 2016. Again, targeted ICS specific attacks that used malware for persistence and remote access for the adversary. I definitely want to mention Trisis, Triton, Hatman here as well that had impact. Specifically, this malware is designed for ICS safety systems. The only purpose of Trisys's life is to disrupt safety systems in plants. So the significance of the threats are definitely getting stronger, definitely more sophisticated. But here's the good news, right? We definitely have an opportunity here to detect the adversary and counter that. And what I mean by counter is not do offense, but counter as in change our environment and mitigate the threats when they're in our environment using network security monitoring to look first. The last point I want to make on this slide is really about how we have been talking about ICS threats. IT threats are absolutely a threat to the ICS as well. And we've seen that recently in the news, and whether it's crypto mining in the ICS, for example, or Configure, Mariposa botnet, which are traditional commodity IT-based malware, absolutely can still have an impact in the ICS with regards to bogging down a network, for example, causing latency in the network, and things like that. So we're definitely talking about ICS today, but I want to make sure people have an understanding that IT malware, like ransomware as well, can also impact your ICS in a very negative way. All right, so the next slide here is active cyber defense cycle. And this is the model that most of the industry uses, which heavily involves network security monitoring. And with that, I'll start on the right side of the cycle here with asset identification and network security monitoring. The objective is to understand what your network does, as I mentioned, understand what assets you have, because you cannot protect what you do not know you have. From there, you can get a good baseline of what's happening in your network, and then decide when you see abnormal activities to pivot into or kick off incident response or not. When you do kick off incident response, the threat and environment manipulation, the next part of the cycle, is how you can reduce the impact of the adversary on your ICS processes. And then again, from that, what did we learn? The feedback loop is the threat intelligence consumption piece. So it's share what you've learned and consume from other ICSs what they've learned as well, and apply that directly to your defenses. So what this graphic and this model really does, it really empowers us as ICS defenders. It gives us an opportunity to look into our network to understand what's normal, what's not, and to investigate what's not. But I'm really optimistic about this, and here's what's really awesome about this. In ICS, obviously, there's a huge difference in the type of users, the volume of users, and the type of traffic and the volume of traffic compared to IT networks. In an IT network, there's a lot more users and things are a lot less static, which means finding that needle in the haystack is a tougher task. But the opportunity we have with ICS, with network security monitoring specifically, is that less users, less traffic, it's easier to find that needle in the haystack. The other thing that's an opportunity for us to take advantage of as ICS defenders is dwell time. Dwell time is significant, and what that is the adversary has to learn more about an ICS than they would in an IT environment to have impact. So for example, we could stand up an ICS at, for example, a cookie factory or an oil and gas facility or an electric power grid. We can have the same implementation plans and ideas in two different states or two different countries, and upon implementation, it's likely the installation will be slightly different to some level. Because of that, because of the complexities and changes, we would then have the adversary having to learn more about the environment. Getting access is only their first step after reconnaissance. Once then they get in, they have to learn more, which means they spend more time in our environment or an environment, which gives us a bigger window of opportunity for detection using network security monitoring, and us to be able to pivot and change our environment to detect and then mitigate the threats that we see. So from my point of view, I'm definitely seeing ICS as a defense and ICS as a really positive opportunity. So with that, hopefully have the ground level, the ground laid here for Dennis. Security Matters is up, how to protect your ICS network with less effort. Dennis Murphy, as mentioned, Director of US Operations for Security Matters. He has several really extremely awesome case studies he's going to illustrate. and it certainly will align with what we've just talked about. So without further ado, I'll pass it over to Dennis.
Hey, Dean, thank you very much. Yeah, that really does line up very well with exactly what I'm going to be talking about here today, which is things that I've seen in the wild when trying to manage threats in an ICS network, and things that we can do to automate that, automate the identification, automate the handling and the workflows that exist around that. But I just want to give a quick background and introduce myself. I'm a proud U.S. Coast Guard veteran. I was a SATCOM and radar technician. When I went to college, I'm not a computer science degree or a double E degree. I went for industrial technology because I had an interest in manufacturing, and I graduated in '93. While I was working, I got my master's at night from Johns Hopkins University in systems engineering while I was working for a defense contractor. So my first 12 years was designing, developing, and maintaining control systems. I worked on everything from making razor blades to golf balls to ice cream, electric utilities, cracking towers, worked on a lot of different control systems and got a lot of great experience. From that, I was actually recruited into a defense contractor in 2005, and I started looking at the security of these things because I was the problem back, before 2005. I was always punching through firewalls, not understanding least privilege and other types of past sins. So then I spent 10 years, I did work at DARPA and Idaho National Labs in doing research and development on control system security. And I've taken that, I've leveraged that for the past 3 years. I've been at Security Matters, and I'm currently the Director of U.S. Operations. So at Security Matters, there's really three things that we look at when we think about cyber resilience. And resilience is what this is all about. It's the ability to fight through when there are things going wrong, and in our particular case, specifically going wrong with your network. And so we provide visibility, right? That's one of the first core tenets. You need to be able to see what your network devices are doing. And I think Dean mentioned it earlier, you can't protect what you can't see. So the first thing we provide you is that set of eyes, kind of looking behind that OT firewall and seeing what's actually happening there, which allows you to assess risks and look at different threats and the different vulnerabilities that might exist, especially where we can see firmware versions and software versions of particular endpoints. And it gives you a better understanding of the current resilience state of your network. And there's something I like to call a degraded state of your network. Everything might look fine on the operational side. Everything on the GUIs, the HMIs is going okay, the process is running, but what's really happening underneath, sometimes even though it's running fine, there's problems on the network. And really that's where detection comes in. So for resilience, you need detection where you can catch known and unknown threats. A lot of times, the greatest part of my job is when I'm actually at a customer and they start looking at something on their network and they go, what's that? I've never seen that before. That's when I know that, okay, they're starting to see the value of doing passive monitoring and how it can help you defend on your network. And we can pinpoint weak spots and inefficiencies in the network. So it's not necessarily just a threat against an endpoint, but also a threat against the ability to fight through because you're not running efficiently. It's very hard to find the problem. By pinpointing that, fixing that, keeping it in a better state, it's easier to fix. Gather all the evidence required for incident response. There's not a lot of forensics information on control system networks. The passive monitoring capability allows you to take all sorts of endpoints that don't necessarily have all of the bells and whistles for IS auditing and record keeping, and allows you in a kind of a one-stop shop be able to sniff all that up and provide that to a larger system that allows you to have the evidence to say that this did or did not happen. Okay? And finally, control. Now, being an OT guy, I'm a control, historical control systems guy. You need three things to control. Number one, you need to have a set point. You have to know what you're trying to get it to, right? So let's say it's an oven and the set point's at 350 degrees. Number two, you need to have an output to be able to say, oh, I need it hotter or I need it colder. And then finally, three is a feedback loop, because I don't know if I should heat it or cool it unless I can see what the temperature is. It's the same way with a network. We need the feedback loop. We have the ability to go and tweak things on the firewalls and the routers and the endpoints. What we don't have is what's actually happening on a day-to-day basis in a real-time continuous fashion to be able to provide that feedback loop very quickly. And so that allows us to know what's going on at all times. We can anticipate then because we know where we're supposed to be and we know that we're not there and we know what we need to do to get back there. And we can prioritize. We can identify the threats against the network, and we can start determining what's the best way to run our mitigation activities so that we're very effective and reduce the time it takes to actually get back to a normal state. So ICS networks are becoming more complex, because I can tell you in 1993, they didn't look anything like they do today from a networking standpoint. And what's happened over the evolution of time is you had an industrial control system network, and one of the first things that I started doing on them was breaking through firewalls to connect them to ERP systems. So this was one of the first, if you will, breaches of the firewall, or they had to, maybe they didn't even have a firewall back then, and they just routed it back to the enterprise side. And, I would work on AS400 systems and take orders and push them down to the control system to say, you have to make, widget model X today. And so that was the first breach that happened. The next one was secure vendor access. Now, historically, vendors would connect in through a modem or dialing in from a telephone. But then they realized, well, we're connected to the enterprise, so why not let our remote vendors come in through the enterprise, and we can kind of see what they're doing. So that was another breach on the firewall side. Next, external alarming systems. If you're the on-call engineer, you don't want to have to sit in the office all day and all night. So you would actually have a system that would dial out the control system and would send text messages or maybe emails, somehow send those high priority critical alarms to you on the OT side. Another breach in the firewall. Mobile reporting apps. Now that you had the alarms on your phone, you now had the ability to get your historical information on your phone and get information about what's been happening with the set points and the process variables. What's the current state? Another breach. And then in the early 2000s, more and more people were realizing, okay, we need to put antivirus on these systems. That was a thing in the 90s, no antivirus on control systems. But now we had to update them because we were sick of writing a CD and then bringing the CD down to every single endpoint. And you put an update server in your DMZ because now you have a DMZ at this point because you have so many things connecting. Patching systems. So you also might have to start thinking about, okay, how am I going to patch? How am I going to apply patches? So you put that on the network. Security auditing reports. Now that we have patching going on, we want to be able to audit. Did it actually happen? What's been happening? Questions come from management saying, can you tell me exactly what's been happening on this network and provide evidence of that? And finally, now SCADA in the cloud. It's a thing. There are companies going to this. The question is, what is the security around this? Yet another breach, and that's beyond a breach because really some of that orange dot is moving into the cloud, some of the services that are actually happening inside. So this is complex. This is a complex network, and there's no one person, right, that's doing this. It's multiple teams. Multiple people are involved at multiple levels. So the C-suite folks are actually looking at what's going on and realizing, okay, we have to secure this. So they give the authority to the rest of the company to say, here's a project or program that we need to run in order to actually secure our control systems, because our shareholders are asking me about this and I need to be able to address these issues with our shareholders. They give the management the directive, and the management takes it from there and says, okay, so let's see what policies apply to us, or regulations if you're in a regulated industry. They actually will take those policies or regulations and start implementing them. And the engineering folks actually look at the technology to apply those policies and to execute the policies. And of course, they all work across 3 different organizations. There's a couple more than this, but these are the main ones involved in the control system. The OT guy, the SCADA guy, if you will, who has obviously the most vested interest in the control system. He's the guy who keeps it running and understands how to keep it running on the process level. The IT person, who is able to actually provide services that OT people traditionally did not know, like routing, gateways, firewalls, even virtualization technologies today, and understand how to apply those. And of course, the information security, providing kind of the coverage around all of that to understand how to keep it secure. So you have these 6 different distinct groups and people, if you will, that have a vested interest and need to help provide pieces of that puzzle to set exactly what the definition of that network is and how they're going to architect it and put it together. So some of the challenges around this, that once you have this network defined, what are the biggest concerns that you have when it comes to this control system network? SANS ran a survey last year in 2017, trying to find, what do you think the biggest concern is, the business concern, when it comes to securing the industrial control systems. And number 1, of course, came back reliability. It needs to run. If I'm not making razor blades or ice cream or golf balls, or if I don't have my electricity electrons pumping out and my taps are stable and good, if I'm not pumping oil, that is a problem. That's what these are designed to do. And reliability and availability is king on that. If we're not doing it, we're not making money. The next 2 are kind of hand in hand, security and safety. And, there's a lot of talk of how these 2 things are really cut from the same cloth. In order to keep something safe, it needs to be secure, right? And you have to have these strategies and these thoughts around, what is it that I care most about on this network? And those 2 come in a close second and third. There's damage prevention as well. We don't want damage to happen to the hardware. It's a little easier to, reconfigure something as opposed to totally rip it out and have to put a whole new one in. So they want to avoid damage. And also reputation. There's reputational issues. If you've been owned and you wind up in the news, that's something people want to avoid as well. But the biggest concern is still reliability, and it always will be. So what are the challenges that these networks face? We look at them in 3 different ways at Security Matters. The first way that we look at this is through cybersecurity. There's a cybersecurity challenge where we want to ensure things like undesired access and flows are not happening. That might be somebody from a remote access coming in and getting to an endpoint that they shouldn't be getting to. We need to be able to see those, what I like to call historical, famous malwares, which is, Stuxnet, Havex, the Ukrainian blackout type of scenario, Triton Crisis. I would even put Conficker in with this. WannaCry, Nimda worms, those still exist out there. If you're not paying attention, it might still happen. So we need to be able to identify when these basic things happen, the ones that we should know about. Firewall misconfigurations, it happens. You know, these are configured by human beings. Somebody makes a mistake and all of a sudden the firewall is misconfigured. We need to be able to identify that very quickly. Or intruders sending corrupt commands. This is meant to be more like a fuzzing or reconnaissance. Somebody's trying to fuzz a protocol and see what they can get at. These types of incidents that might occur can cost quite a bit of money to mitigate. A lot of people get involved. The frequency, though, isn't very frequent. It doesn't happen a lot. I put this in the insurance category. You know, cybersecurity is kind of like the insurance game. You know, you're putting, there's no return on investment that you can say, we're going to now make this many more widgets because we're secure. The return on investment is just we can ensure and provide more reliable operation and reduce the cost of any intrusions that may occur. The middle one, infrastructure. The middle challenge is more about the network itself. Failure and downtime of critical devices. We need to be able to see if that's happening. Routing or gateway issues. If something can't get to where it's supposed to go, you know, the networking infrastructure is misconfigured. Data sent in non-compliant format. This can actually happen because of hardware issues and bugs. I've seen an issue where a Modbus system was communicating improperly because it was just a hardware failure on a card. That was a threat to the network. It wasn't working properly, and it could have caused downtime had it continued and totally failed. Connectivity issues with the field devices. These impacts are real. They're not quite as large as a massive intrusion like cybersecurity in cost, but they happen a little more frequently. Weekly, yeah, it could be, or monthly. You know, you might find something like this, especially if you're in a very large end user. And finally, operations on the right. So operations is all about the actual process going on, and one is like use of insecure protocols. So maybe Telnet is not allowed by policy, especially to, you know, maybe it's limited to a certain number of endpoints. We want to know if something is happening outside of that. Incorrect process measurements. Something is coming back and maybe it's either offline, it's been labeled offline, or it hasn't changed very often, or there's some error coming back. Misconfigured devices, maybe something isn't talking NTP properly. Also unstable process variables. And in this particular case, with unstable variables, I'm not talking about, oh, it should be between 200 and 500. That part is taken care of by the SCADA system, and usually they have alarms set. What happens more often here on our side, monitoring the network, is attribution. Attribution of, if this goes off of where it should be, okay, where did that come from? And that's where we can help out. That's where the network security monitoring capabilities can provide you that attribution to say either, yeah, that was just something that happened, you know, in a normal communication, or this was not normal communication and it shouldn't have happened from here. Or maybe it's part of a tactic and technique that might have been seen in the past. You're able to actually do that analysis because we've enabled you to see those forensics on the network. So the impact can be smaller, you know, happen more often. But this is really where some of the ROI for putting a system like this comes in, is with operations. And the average cost per hour of unplanned downtime is roughly $260,000. This is actually from multiple sources. You know, it's kind of an average of different sources that we've seen. So it is not a small number, and it's very easy to see how this can quickly pay for itself. So let's look at 3 real-world scenarios. The first one we're going to talk about is a cyber one, looking at more of a cyber type of incident that occurred. The second one is operational. It's squarely about control system and a PLC. And the third one is about integration. And it's integrating this threat management into the workflow of that particular end user, and how we can automate that. So first, detecting and preventing cyber threats. This is actually becoming harder to do as time moves on. Over time, the personal knowledge of these control systems is decreasing. And what I mean by that, this is kind of echoes what Dan Greer talked about at his Black Hat keynote a few years ago. He mentioned at that time that it's impossible for one person now to really know everything about their computer. It's getting more and more impossible because of the complexity and to understand how to make that. In 1960, it was very different. You could actually have one person that might know that. And if you keep pushing out for the next 20 or 30 years, it just keeps getting harder and harder and harder with the more complexity that exists. So that leads to the inability to diagnose your problems. It's harder to do that by yourself. The available time to manage the threat is reduced. The usefulness of your indicators of compromise is reduced over time because each indicator is only one smaller piece of the larger puzzle and has to be correlated and put together. And what's increasing over time, obviously, is the complexity, as we've said, and also IT technologies that are being used in the OT world. That is increasing. And this is for economies of scale reasons. Threat actors and capabilities, the ability of threat actors to get into your network is getting increased more and more. The sophistication of the attacks, they're becoming more and more targeted. Dean talked about that in his earlier slides. I don't have to talk about that. And ICS focus versus IT is increasing. More and more people at the end user level, and I'm talking about the whole organization now, not necessarily just the OT groups, but the whole organization understands that, okay, now we have to think about this and worry about this, and how can we help the OT people deal with this? So the first scenario is a WannaCry infection that we saw. It was at a Midwest oil company. They had several nodes with infections inside their OT perimeter. And 2 questions were asked of us. Question number 1, can we identify any WannaCry activity on the network with your product? And the answer is yes. Question number 2, can we validate if SMB version 1 is running over the network? And I'll explain why that question was asked in a minute. So we can monitor kind of like, again, 3 different ways. The first one is monitoring anomalies out of the box. Looking for, various RFC violations, malformed messages, anomalous behaviors. A good example that I give people of this is that if you have a string field in your protocol and there's something other than ASCII readable text, like an end of transmission or a no-op or something like that in the field, non-printable ASCII character, we highlight that. Why was that there? That shouldn't be there. So that's an example of, okay, this is beyond what should be in there, and we can alert you of that. And finally, in the anomaly section, we can grab this prior to any known malware indicators being published. So we're not going to know that it's Eternal Blue or Double Romance or, Eternal Romance or Eternal Blue or Double Pulsar, but we're going to see some of the odd pieces of that going on, and we actually can historically look up, did that occur in the past based on those detectors? They may not tell you much right now, but to forensics people and threat hunters who are out there looking at this, it's a treasure trove of information. In the middle, monitor threat indicators. we actually, once we do know the indicators and it's been published and there are intelligence houses that publish these indicators, we can go looking for them and we can actually create a package that says, okay, now look for these from this point forward in the network. And so we deliver that to the customer, and then they can see, okay, yes, I can tell you we don't see this happening at all right now in the network, or maybe we do see it happening. And finally, the policies. So a lot of companies, some people think of this as like automated learning or behavioral learning, but we always bump that up against what is your policy? What do you think normal should be, Mr. Customer? And we can put that in the product and help you monitor policies of what should be going on. And this is done not only on whitelists, but on blacklists as well, and some learning and some custom tools that we have. And so in this particular case, in this scenario, the solution for this customer was, one, looking at the malformed packet analysis and, being able to identify invalid values in the fields. We did see some. The good news was it wasn't actually WannaCry activity. We weren't seeing it. So they had already had the infection, and we came in afterwards to take a look. And the good news is we were like, okay, so we know that there's no weird things happening with SMB. Number two, we added our extension, which identifies Eternal Blue, Double Pulsar, and Eternal Romance. And we enabled that. So if we were to see that, it would pop up. Again, we didn't see anything. So we were like, okay, you are now, we know that's pretty clean. And we were monitoring 24/7 after that. But that second question of, we want to know about SMB v1, because we know that's the vulnerable version of SMB. And we've told our OT people to shut that off everywhere. And so they used our product to say, I said, okay, we can quickly put in a policy, no SMB v1. And we quickly got a list of all of the systems that were using SMB v1. And I remember the person saying, oh my gosh, they said they weren't using it anywhere, but they're using it in this dozen or so places. So they were able to realize and identify that problem, remediate it, and now the continuous policy monitoring is in place, and they can do that moving forward.
Dennis, I got a quick question there. Absolutely excellent example, and I really want to highlight a couple things that are of really significant value for the listeners. So the IT and OT convergence you mentioned there, like everybody working together, super valuable. We're seeing that more on the utility side as well, and that's really an excellent way forward. The question I have is, what about your thoughts or opinions on automated threat hunting? Like, I know what I've seen in the community, resources can be limited. Tools are definitely a necessity to a large degree, and people obviously to manage those tools. But what about automating the tools for threat hunting? What kind of thoughts do you have on that?
Yeah, that's a great question. And I want to be very clear here that automated threat hunting, is not, threat hunting is a specific activity that's done, quite frankly, usually by human beings, because they're looking for uniqueness and they're looking for maybe particular tactics or things that are different. What we provide is an automated, gathering of intelligence for threat hunters. Okay, and automated threat hunting is an evolving technology and an evolving practice. There are a few folks that are working on this, and there's many tools that you can use to do automated threat hunting. But what the real thing that you have to worry about there is, how does it fit in with your workflow? How are you going to actually take the automated threat hunting activities and do something with that, and provide more than a report, because a report is great, but you also have to have that flow back in somehow into the practice that you're doing as you're going through and working on your networks.
Right.
So that's my thoughts on that.
No, excellent. I can see the tie-in back to active defense here as well. Thank you.
Yep, absolutely. So scenario 2, I got 2 more to go through here. Uncovering hidden operational information. This particular one is about the ICS control system that had some operational information that wasn't actually being reported up to the SCADA system. This was in Texas. It was an oil and gas customer. We actually went in to do inventory. This is a very typical story. You know, customers are very interested. I need to know what I have. I need automated inventory. Okay, we put our system on. We find the inventory, but all of a sudden they see, well, what's that little red dot over there? Okay, well, those are our anomalies. And then we go start taking a look at them, and they go, wait a minute, I didn't know this was going on. I didn't know that was going on. What is this? So what happened was we detected several anomalies while we were doing this, and then at the management level, they started hearing about it. They said, listen, we want to report on this. You know, what can you tell us about our operational network? You know, can you find like unauthorized or unwanted activity on the network and report on that? And so again, the answer is yes. We have our industrial threat library, which allows us to monitor right out of the box quite a few different anomalous operational behaviors, you know, like relevant file transfers, right? So we can log those types of things that are going on. Recent threats from intelligence sources will actually, like blacklisted IPs, we can let you know if we see a blacklisted IP from intelligence sources. Opening and closing of too many switch breakers, we, you know, specifically for DNP3, if we start seeing many breaker operations, you know, select, operate, select, operate, select, operate, all in a certain amount of time, we alert on that. Message replay attacks, insecure passwords and protocols, and OPC misconfigurations. Now, in this particular case, we were at the customer, and one of the alerts, which was an OPC misconfiguration, caught the eyes of one of the controls engineers because it was coming back with an error. And it pretty much said, hey, there's an invalid tag name being requested from the OPC server. And it turned out that as we looked into that alert, the OT guy, the control system guy, said, oh, I know what that tag name is. That shouldn't be there. Why is it requesting that one? That's a configuration from 2 months ago. And then he went in and simply went to the OPC server, reloaded the new configuration, and then those alerts went away. And in box number 3, we were able to watch, right, once the configuration was fixed, that the alert flow went to 0. That's that positive feedback mechanism I was talking about, that you can see immediately that you've had an impact on the network and it's not happening anymore. And so the silent defense system helped to communicate exactly when that threat had been remediated, and our automated reporting capability was allowed them to kind of see exactly when it started and when it stopped. And we were able to report out on that.
So we got a quick question there, Dennis.
Yeah.
So SCADA systems in general and automatically, mitigating operational threats. Can SCADA control systems automatically mitigate operational, threats? Can you discuss a little bit about that? Why it's a good idea, if it's possible?
Yeah. So control systems, they see these errors, because I used to work for a control system vendor, and they're able to actually see that the error is going on. But the question is, how does the operator know that it's happening? It has to be coded into the operational interface, the HMI. And even if you code it into the interface and you tell that operator, hey, you have an invalid tag name, the guy on third shift, turning the machine on and off and making it run may not fully understand what that even means. So it's this layer that the engineers understand, but in order to see it, they have to go into logs that might be sitting on a hard drive somewhere and start pouring through them, looking for the errors, looking for the alerts. And it's very difficult to try and find this information, which is why network security monitoring allows you to kind of pull that out and aggregate that in a location where people can start monitoring that and do something about it and report on it.
Excellent.
Okay. And finally, the final scenario, managing threats in a large complex network. So our largest customer in the United States has many, many, many sensors in many different, 6 different areas. This includes power generation, electric distribution, transmission, gas compression, gas control centers, and battery storage. And what happens with this is this particular system, they said, okay, we're getting all these great alerts, right? But we need to do something with them. What's our best way to react to things going on in this network? And so they had Splunk, and we obviously could integrate into Splunk, and we provided them with data. But we have over 900 alert types. And so we realized that we had to do something to make this more usable. We weren't going to send 900 alert types to an SOC. We had to start prioritizing. And so the internal IS group that's focused on OT, looks at alerts every week or so, every few days, every week, every other week, looking for things that are kind of odd. But they were like, okay, we want to forward those high severity, high confidence alerts to the SOC. So their question immediately was, all right, so how do you define a high severity, high confidence alert? And then finally, how do we integrate an automatic workflow between the network security monitoring and the 24/7 SOC? And so we were able to answer both of those questions. So first of all, integration with Silent Defense. We're building the product not as a single product that does everything. We build it as something that will fit into somebody's cybersecurity practices and other technologies in their enterprise. So we're looking at, we have a RESTful API, and we can integrate with asset management tools. We can do on-the-fly firewall reconfiguration, although I will say nobody does that in production today with our system. They're doing it in research and development labs, but it is working, and it's technology that will be coming out in the future for production systems. Security sandbox submissions, so Palo Alto Wildfire, we can take file samples and send it over to Palo Alto's Wildfire sandbox to take a look at the file. We can connect into Active Directory so that we have single sign-on, and you don't have to do user management of our system. It's done from a central location, and you get all of the logging capabilities of that and the auditing capabilities. And finally, we also have integration with major SIEM solutions. In this particular case, it was Splunk. And we have a Splunk app with the product. So the solution here was, the thorough risk analysis to identify and route alerts that are very severe and high confidence, such as like malware, that we have high confidence in the indicators of that malware happening across the wire. A good example of that is Stuxnet. It's a very specific GUID on the DCOM interface. Aggressive scanning techniques, blacklisted credentials, denial of service, Christmas tree scans. These are things that you shouldn't see and rarely see out in the wild. And so we put those as the high confidence and high severity alerts. The Splunk app sent it to Splunk, gave them the context of information around that. And then the example of when this really went right was in their gas control center, there was a login failure using blacklisted credentials at 2 a.m. and the SOC got it. So the guy at the SOC was sitting there going, okay, so I got this alert. And we had given them a call list and a procedure of what to do. They analyzed it, figured out who they needed to call and what information they needed to provide. So they gave immediate contextualized feedback within 15 or 30 minutes back to the control center and said, hey, this is going on in your network. They called in the engineer who was on call, and by 8 o'clock the next morning, they had figured out that it was actually a backup system that somebody had configured the day before, and they configured it improperly. So although it wasn't an intrusion, it really gave them confidence that if somebody started trying to ping any of their FTP servers or HTTP servers with bad credentials, they're going to know about it immediately, and they're going to be able to react much quicker to what's going on. This system, by the way, only gets about 10 to 12 alerts per month. It's not a ridiculous number. It's a very reasonable number. Some things like this happen very quickly and they can remediate it quickly. Other things might take a month because it's more complex and they're trying to figure out what's going on.
Dennis, we talk about integration there quite a bit, which is good. What about the integration and the value of integration for asset management tools? Obviously, we need to know where the assets are. How do we track an incident through different assets? So can you speak a bit about integration of asset management tools at all?
Yeah, and actually that was part of this because the SOC folks were trained on how to get the asset management information out of the tool so that they could then contextualize and see what is it that I'm talking about here. So it was important because if an IT guy sitting in a SOC calls an OT guy sitting in a control center and they're speaking a different language, I can tell you right now, it might as well be, French and Chinese. They're not going to know how to talk to each other. And so providing that inventory information is very, very important in an automated fashion so that that contextual information can allow them to communicate the problem and resolve it much quicker.
Excellent. I mean, back to the points we discussed earlier about network security monitoring, the crux of that being asset identification.
Yeah. So conclusion, they have some unique challenges that we've talked about on cyber operational and on the integration side. We use an ICS cyber resilience model. Our input is getting intelligence from public sources. We get it from many different sources, as you can imagine. Our industrial experience, I think we have a very diverse and decent team of people who work together to put our experiences together to create these unique behavioral, interesting anomalies that help a customer identify things that shouldn't be happening in the network. And of course, customer feedback, customers telling us what they want and what they like and what they don't like about it, what we're doing. And we have a process internally with that. We have an operations team and a development team that puts all of this together. And we provide the product, Silent Defense. That's one piece of it. We also have services, but all of our services, I want to be very clear on this, revolve around the Silent Defense product. If you don't have the Silent Defense product, we are not a pure services company, but we can help, like we did with that customer in the last scenario, to automate some of the workflows and help you create those contact lists and the processes, the standard operating procedures on that. And of course, threat management packages, which we do send out to update the product. So the key takeaways: know your network, know yourself. You're going to need to know that to be able to secure your network. Choose tools and partners that are able to help your process and needs as a whole. Don't look for the tool that has just the whiz-bang thing that can identify one particular threat really well. You also need to see how does that fit into all of your workflows. Think about questions that you'll be asked by your management, because the last thing you want is when something goes wrong for your management to come down with a question that you're unable to answer. Do some table exercises, for instance, where you can start seeing where the gaps in knowledge are, where your gaps are in terms of evidence and information that you might need to provide your organization to properly respond to issues. And use a risk-based approach, right? So prioritize. There's going to be, I don't care what product you use or what tool you use, there's a lot of information that actually comes out of monitoring a network. And so by using a risk-based approach, you can prioritize and understand how to bubble up all of the important information up to the top which increases your productivity and your ability to respond to these things that are happening in the network. And with that, I'll take any questions.
All right, thanks for that great presentation. We have a couple of questions ready for the Q&A. Can you automatically identify endpoint vulnerabilities?
Yes, we can. We can identify vulnerabilities through a few different mechanisms. This includes vendor, the make and model of the particular endpoint. So especially if it's a PLC or an RTU, we're able to pull that passively out of packets that are going back and forth, as well as firmware versions. So firmware versions are typically provided as well in a lot of packets that go to these control system controllers. And in some cases, we can actually see software versions. It's a unique thing, but like in ICCP, which is a intercontrol center protocol for the electric utility, they pass not only the name of the software, but the version of the software that's being used. We can also look at endpoint versions of certificates that are being used as well, and the SSL versions that are being used going across the network. And that helps automatically identify the vulnerabilities.
All right, thanks. I think we have time for one last question. How do you determine the confidence level of alerts?
Yeah, and that's the trick. So there are alert types that are, from a confidence level, you may not exactly know that it 100% was caused by something that is a threat to your network. And I'll give you a concrete example of one that you know is a threat. For example, a Christmas tree scan or a null scan. In other words, if no flags are set on the TCP layer of the packet, or all flags are set on the TCP layer of a packet, I can say with my experience and the over 10 years I've been doing security, I've never seen that happen accidentally. As soon as that happens, there's a high confidence that that's a problem. And we go through all of our alert types to identify if it's a high confidence or a low confidence. Blacklisted IPs, that's a high confidence. Blacklisted users, that probably is not quite as high as others, but it's up there. Ones that we're not as confident on are things like port scans or man-in-the-middle attacks. Those are not super high confident, but they do, because sometimes there are things that really happen in control systems like ARP poisoning to do redundancy. Some control system vendors use the ARP poisoning technique to actually do redundancy. And so therefore, that's not a high confident alert. And we go through all of those 900 alerts and create the confidence levels using heuristics like that.